Hello friends, welcome back to our YouTube channel. So in the previous videos we have covered few of the most important interview questions, and today we'll be covering one of the most important interview questions, that is the what is the architecture of JVM, or we can say how JVM works internally, or we can say how what is the working of JVM. So this is one of the most important interview questions asked by the interview. So let's begin. So working of JVM. So basically, as we know that, as we have covered in the previous videos as well, what is JVM? So JVM stands for Java Virtual Machine. It is a part of JRE. JVM is the one who is responsible to call the main method. So as in the previous videos also we have covered what is JVM, and JVM is nothing but it is one of the important part of the JRE, and JVM is also responsible to call the main method. And as we know that because of the JVM, Java is platform independent language as well. Java applications are Vora, that is write once and run anywhere. This means once we deploy the Java program on one machine, and we can execute it on multiple machines. This is the Java platform independency because of the JVM. When we compile a .java file using Java C compiler, .class file is generated with the same class name present in the .java file. This .class file undergoes various process or steps. These steps describe the whole JVM system. Now, basically, when what happens when we compile the .java file, or we can say a Java code, using the Java C compiler, a new .class file is created, or we can say a bytecode gets generated after the compilation of Java code. this this .class file will undergo various different processes or steps, we can say. These steps or the process describes the whole internal working of the JVM. So we'll looking further step by step into it. Let's move ahead. So this is the diagram which will explain the architecture of the working of JVM. So basically, when we compile the Java code, it will generate one .class file. .class file. This .class file will be loaded by the class loader. Class loader is nothing but it is an important part of JVM which is used to load the .class file. Now there are different types of class loaders. That is a separate internal working of class loader that I will be covering in the next video. So today we'll be focusing on how JVM works internally. Now there are different types of memory managements by the JVM. There are 5 different types of memories, that is the method area, heap area, stack area, PC register, native method stack. Now we'll be going through one by one of each memory area, what it describes in exactly. Then next comes the execution engine. So execution engine executes the bytecode and runs our Java program. So we'll be going detail into it again. Now there is a native method interfaces, so it contains the native method interfaces and native method stacks. This also we'll be looking into detail. So let's begin step by step. Now the first step that we have seen is the class loader. So basically, what is class loader? So basically, class loader is nothing but it is an important part of the JVM, and it mainly performs 3 activities, that is the loading, linking and initialization. Loading, linking and initialization. So basically, in the loading phase, what happens when we try to compile the .java file, a .class file is generated by the compiler which contains the bytecode. Okay, in this phase the class loader loads the .class file and generates the corresponding binary code and saves it into the method area. So basically, when the .java file is compiled by the Java C compiler, it will generate a new .class file with the same name of class name present in the .java file. So we have a .java file. Inside that we have a class. Take it as an example, class A. It will generate a .class file with that class name, that is a.class. Okay, and now this class loader will load that .class file, and it will generate the corresponding binary data or the native code, we can say, and saves it into the method area. So method area is the first part of the JVM memory management. We'll be looking into detail into it. So after loading this .class file, JVM creates the object of type class. So once the .class file gets loaded by the class loader, now what the JVM will do, it will create the object of type class. Okay, so in our example, suppose the JVM will create the object of class A to represent that dot class file as in dot class file as a part of heap memory. Now whenever we create the object using new keyword, so that object is stored into the or gets the allocation into heap memory. So that's what I want to explain. After loading the dot class file, JVM creates the object of type class to represent that dot class file as a part of heap memory. This object can be used to get this object contains basically the class level information like the name of the class, the parent class name, then the methods, objects, etc. I hope. So basically in the loading phase we can just consider the class loader. In the loading phase it will just load the dot class file, it will generate the corresponding binary data and saves it in the method area. After that the JVM will create the object of that particular type of a class and to represent that file as a part of heap memory. And what that object contains, it will contain all the class level informations like the name of the class, parent class name, methods, fields, etc. Now the second is the linking phase. So basically in this phase it ensures the correctness of the class. Correctness in the of the dot class file means it will check whether the generated bytecode is generated correctly or not. So when we compile the .java file, it will generate the bytecode. So in the linking phase, it will just check whether the particular bytecode generated is correctly generated or not. It will make use of an bytecode verifier to verify the uh, bytecode. So basically in the initialization phase, all the static variables are assigned with their values defined in the code and static block if any. So basically if there are any static variables defined in the code, so it will get initialized with the values defined in your code. This block gets executed from top to bottom in a class and from parent to child in a hierarchy. So it will be executed in a top to bottom manner in a class and in a hierarchy wise from parent to child. So this is the first step. So mainly the class loader is responsible to perform three steps, that is the loading phase, linking phase and the initialization phase. So in the loading phase it will load the dot class file and it will generate the corresponding bytecode and saves it into method area. And after that, once the dot class file is loaded into the method area, the JVM will generate the object of type class to represent that file as a part of heap memory. And what does that object contains? It will just contain the class level information like the method area, methods inside the class, parent class, name of the class, objects, variables, etc. So second is the linking phase. In the linking phase, it ensures the correctness of the dot class file. It will make use of a bytecode verifier to verify the whether the generated bytecode is generated correctly or not. In the initialization phase, all the static or the local variables or the static blocks, if there are any, it will this block it will be assigned with that values in the whatever you have mentioned in the code. So this block gets executed from top to bottom in a class and parent to child in a hierarchy. So I hope you have understood the first step. So moving forward, second step is the again the class loader. So basically there are three types of class loaders. Okay, so first one is the bootstrap class loader, second one is the extension class loader, third one is the application class loader. Bootstrap, extension and application class loader. So what all these three classes do? So basically bootstrap class loader loads the classes from the rt.jar file which is present in java home lib directory. Second is extension class loader. It loads the class from extension directory present in java home jre/lib/ext. Application class loader. It loads the classes from the class path specified by java.class.path.environment variable. So in the last video we have checked the class not found exception. So if the particular class is not found in any of the three types of class loaders, or we can say if the if any of the type of class loader is not failed to load that particular class, then it will throw the class not found exception. So this is the detailed diagram of class loader, how it works. We'll be looking into detail of class loader, of internal working of class loader in the further video. comes the JVM memory management. So there, as we have seen in the diagram, there are 5 different types of memories managed by the JVM. So first one is the method area. So basically, whenever we load the or whenever we compile the .java file, a .class file is created, right? So this .class file contains the bytecode. Before loading this .class file, or we can say after loading the .class file by the class loader, it will correspondingly generate its native code. Native code, as we have seen in the last slide. Yeah, over here it will generate the corresponding binary data and saves it into method area. So it will, the class loader, once the class loader loads the .class file, it will generate the corresponding binary data for that particular .class file, and it will store it into the method area. Okay, now it contains all the class level information like the class name, method, variable, the parent class name, etc. All this information will be stored in the method area. Now once the particular .class file is loaded into the method area, now the JVM will create the object of type class using new keyword. Once the object is created using new keyword, then that .class file is represented as a part of heap memory. So all the information related to object, when we are creating the object using new keyword, then then that particular object gets the memory or the references into the heap area. It is a shared resource. It is also a shared resource. Then second one is the stack area. Third one is the stack area. So for uh, what we can say, in whatever the local variables, global variables, or the static blocks or the static variables that we have defined into our code, that particular variables or the static blocks or the static variables will get the memory inside the stack area. So for every thread, JVM creates a new runtime stack which is stored here. All local variables of the method are stored here. When the thread gets terminated, the stack will be destroyed. So whenever in multi-threading environment, so whenever a new thread gets created, JVM will create a new runtime stack, and which will be stored in the stack area. Then once that particular thread has completed its process and it will get terminated, then the particular stack will get destroyed by the JVM. Third one is the PC register. So PC register, so basically it what PC register will do, so it will store the address of the currently executing thread. It will store the address of the currently executing thread. Native method stack. So a separate native stack is created for every thread. It contains all the native method information. So basically, first we'll have to understand what is native method. So basically, native methods are nothing, are the methods that are not developed in Java, but they are developed in the other languages excluding Java. Means like we can say we are using a Java application and the methods are developed in Python. So and we are using that method in our Java class. So that is called as a native method. For that methods, we have a separate native method, native stack for every thread, and it contains all the native method information. So I remember, if I'm wrong, uh, in multi-threaded environment we have a one native method information, native method. So we'll be covering in the further videos that also. So I hope you have understood the memory management with the JVM. So the interviewer might ask you what are the different types of memories managed by the JVM. Now I hope you should be good to answer. So there are 5 different types of memories, that is method area, heap area, stack area, PC register, native method stack. What does method area contains? It contains all the method all the class level information like the name of the class, parent class name, methods, variables, etc. What does the heap memory contains? It contains all the whenever we create the object of a class or any object that we are creating using new keyword, so that particular object is stored in the heap area. What does the stack area contains? It contains all the local variables of the method, or we can say static variables, sorry all the local variables of the method are stored into the stack area, and for every uh, thread, a JVM creates a new runtime stack, and it will be destroyed when that particular thread is destroyed. Native PC register, so basically it contains the it stores the address of the currently execution thread. Native method stack, a separate native stack is created for every thread. It contains all the native method information. So we'll be moving further. Now fourth step is the execution engine. So basically execution engine executes the dot class file which contains the bytecode. Now whenever in the like few minutes before I have covered that whenever we compile the .java file using javac compiler, it will generate the dot class file. What this dot class file contains, it contains the um, bytecode. So now this bytecode is executed by this rule engine, but this particular rule engine is described into different parts. So basically execution engine executes the dot class file or the bytecode, we can say. It reads the bytecode line by line and executes them. It can be classified into three steps, that is interpreter, just-in-time compiler, and the garbage collector. So I hope if you guys remember that in the previous videos I have already covered what is just-in-time compiler. Okay, but we'll see the internal see the working of it as well over here. So first is the interpreter. So what does this interpreter do, and for why it is needed? So interpreter, it interprets the bytecode line by line and executes them. It reads the bytecode line by line and executes them. But the disadvantage over here with the interpreter is that whenever it sees the same method call for multiple times, every time reinterpretation is required. Okay, what this reinterpretation will do, it will reduce the performance of the program. I hope you guys understood. So the interpreter interprets or reads the bytecode line by line and executes them. The disadvantage here is that one when one method is called multiple times, every time reinterpretation is required, due to which the performance of the program is gets down. Second is the just-in-time compiler, JIT compiler. So it is used to increase the performance of the program to overcome the disadvantage with the interpreter that the interpreter have. To overcome that disadvantage, just-in-time compiler was introduced. It is used to increase the performance of the program. So what interpreter will do, it compiles the entire bytecode and changes it or converts it into the corresponding native code. So whenever it sees the same method call for multiple or for this for multiple times or repetitively, it will not reinterpret the whole bytecode. So what it will do now, it will just provide the generated corresponding native code. It will not reinterpret the whole bytecode. Once it will interpret the whole bytecode only once. It compiles the entire bytecode and changes it into the native code. So whenever it sees the same method call for multiple times, it will just provide the corresponding generated native code. It will not reinterpret the whole bytecode again. Okay, JIT compiler provides the native code, so reinterpretation is not required, and hence it improves the performance of the program. Got my point? Like JIT compiler, it is used to increase the efficiency of the program or the performance of the program. Whenever it will see the same method call for the multiple times, it will not reinterpret the whole bytecode again and again. It will just for the first time only, what it will do, it will just convert the corresponding bytecode, and it will convert that bytecode into the corresponding native code. So whenever it sees the same method call for multiple times, it will reinterpret the whole bytecode. It will not it will just provide the corresponding native code, and hence and due to that, the performance of the program is improved. Now garbage collector, so basically it is used to delete the unreferenced object. The objects that are not used or that are unreachable are deleted by the garbage collector. So we have a separate video, the whole internal working of garbage collector as well. You can go through it. So next is the Java native interface and Java native method libraries. So basically native interface is nothing but we can say these are the interfaces that are developed in some other languages. So basically it is an interface that interacts with the native libraries and provides the native library for the execution. So it is just used for the interaction purpose between the native libraries and provides the native libraries for the execution. What is native method libraries? These are the collections of native libraries which are required for executing the native methods. So whatever the native methods that we are using um, uh, uh, to interact with that, or to interact with that, we are using native method libraries. So I hope I have covered all the internal working of JVM. So you can, so basically this diagram explains you the mm, whole JVM architecture. So in short, we'll look into it again. So basically, whenever we compile the .java file, it generates the .class file. So now this .class file undergoes various process. The first step is class loader. The class loader loads the .class file. Now whenever it loads the .class file, it will generate the corresponding binary data for it and stores it into the method area. Now it will now the JVM will create the object of type class to represent that object as a part of heap memory. Okay, then stack memory contains all the local variables, static blocks into it. PC register, it stores the address of the currently executing thread. Native method stack, then rule engine exception. Inside the rule engine exception, there are three parts: interpreter, JIT compiler, and the garbage collection. Then native method interface and native method stack. I hope you guys have understood with the internal working of JVM how it works. If there are any questions, please let me know in the comment section. Thank you. And if you are new to the channel, please do like, share, and subscribe to the YouTube channel.